In this module, we will be considering some of the basic properties of vectors and scalars. Something is said to be a scalar if it can be quantified by a simple numerical value along with an appropriate unit of measure. Listed below are a few example scalar quantities along with their appropriate units of measure. More complex things can also be described in terms of sets of scalars. For example, color. We might consider the sets of red, green, and blue colors together as a set, or we could also represent it as hue, saturation, and brightness, or cyan, magenta, yellow, and black. Direction can also be thought of as a set of scalars. Common sets are altitude and azimuth, or right ascension and declination. A special set of quantities is so geometrically intuitive and can be used to describe so many different things that it has been given a name of its own. It's something called a vector. Now, a vector is used to represent something that has both a magnitude and a direction. The magnitude of a vector is a scalar quantity. It's a numerical value along with an appropriate unit of measure. In one dimension, a plus or minus sign associated with a magnitude can be used to indicate the direction. If we go to higher dimensions, then each additional dimension requires an additional piece of information to specify the direction. There are many familiar examples of vectors: displacement, velocity, acceleration, among many others. In terms of notation, in textbooks, vectors are often denoted by bold-faced letters. For example, bold-faced R for displacement, bold-faced V for velocity, A for acceleration. More common notation, especially when written by hand, is to use an arrow over the letter. So an arrow over R means displacement, an arrow over V, velocity, and so on. We also have representations of vectors. There's a graphical or geometrical representation in which the vector is presented as an arrow, and there is something called component notation, which we'll learn more about later. In the geometrical representation, the vector is represented by an arrow. The length of the arrow is the magnitude of the vector, and the direction of the arrow is the direction of the vector. So in 1D, we have either arrows which are pointing to the right, which would have positive values, or vectors pointing to the left, which would have negative values. If we go to 2 dimensions, well, we now have the freedom to rotate those vectors around in a plane. And if we go to 3 dimensions, well, this becomes a little bit more difficult to draw, especially by hand, but we can now move these vectors represented by arrows to point in any direction in space. There are 2 basic ideas that give you nearly everything you need to know to work with vectors. First of all, you can move a vector around by carefully keeping it parallel to its original direction and without changing its length. If you do this, then the new vector is equal to the original vector. Second, you add 2 vectors, say vector A and vector B, by moving B so its tail is at the head of A. The result of the addition is the vector with its tail at the tail of A and its head at the head of B. And this gives you the vector A plus B. Vector addition is commutative. That is, adding B to A is the same as adding A to B. It doesn't matter which order you do it in. We find the same resulting vector A plus B. Furthermore, vector addition is said to be associative. So if we have 3 vectors we're adding together, A, B, and C, we can add the first 2 vectors, A and B, together first to get A plus B. Then we can add C to that to get A plus B plus C. But we can also start by adding B and C together if we want. Then we can add A to it, and it gives us the same vector. And we can also add them in a different order. We get the same thing. The negative of a vector is simply the same vector but in the opposite direction. So it has the same length, but the opposite direction. And if we add the negative of a vector to a vector, we get 0. Subtracting a vector is simply adding the negative of a vector. So if we want to subtract b from a, we first find the negative of b, and we add that to a to get a minus b. If we multiply a vector by a scalar, well, the simplest way to understand this is first of all to multiply a vector by an integer. So if we multiply a by 2, then this is the same thing as adding a to a, and clearly the result is a vector in the same direction as a, but with twice the length. So if we want to multiply a vector by a non-integer multiplicative factor, let's call it m, then if m is larger than 0, then the resulting vector is in the same direction as a, but has a magnitude that is m times the magnitude of a. If the multiplicative factor is less than 0, then the result is in the opposite direction of a, but it has a magnitude which is the magnitude of m times the magnitude of a.